All right, let's get started. Hello, everyone. Welcome to today's session. I'm Vinay. Today's topic is implementing SOC use cases with IBM QRadar SIEM.
So, hi everyone. In this session, we will explore the concept of use case framework and its critical role in organizing and managing detection use cases in security operations. We will begin by discussing different types of frameworks. Specifically, we will dwell into the SPEED framework, which provides structured guidelines for log source detection and consistent naming conventions. Then the Sigma framework, which is known for its flexibility and adaptability across various SIM systems. Additionally, we will cover Yara rules, a powerful tool used for malware identification through predefined patterns. Thereafter, we will walk through a business use case along with the demo on how we can implement SOC use case in QRadar. Let's start our discussion with what is a use case framework. A use case framework is an analytical tool that has a series of cybersecurity related distinctions that facilitates the organization of cybersecurity detection rules. The objective of building a use case framework is to better protect the organization's valuable assets by designing and developing detection use cases using a holistic approach that connects regulatory compliance and threat requirements. The framework provides more control over its detection coverage and ongoing development. Now that we know what is a use case framework, we shall now know why a use case framework. A use case framework is essential for providing a holistic structure where detection use cases can be systematically categorized. This framework serves as a reference point, enabling organizations to easily identify gaps in their existing use cases and prioritize areas that need more attention. By organizing use cases within this framework, teams can take a phased approach to expanding their detection capabilities. This method allows for the integration of a wide range of inputs, such as evolving threats, business priorities, and compliance requirements, ensuring that new use cases are developed efficiently and strategically. In a security operations center, use cases define scenarios for identifying threats, guiding incident response, generating alerts, and proactively searching for threats. They also ensure regulatory compliance and streamline SOC operations. Now we will know how to convert use case to rule by understanding its life cycle. This diagram illustrates the use case life cycle, a continuous iterative process for managing use cases. The cycle begins with defining or reviewing the requirements of a use case to ensure the goals and objectives are clearly understood. Once the requirements are set, the next step is to identify the necessary data sources that will feed into the use case. After identifying the data, the process moves to onboarding these data sources, which involves integrating data sources as needed to ensure accurate and reliable input. Following this, the cycle progresses to the design and review of the detection logic, the rules and logic that determine how the use case will detect threats or anomalies. Once the logic is in place, the baseline is defined, which serves as a reference point for normal system behavior, helping to identify deviations. After establishing the baseline, the use case undergoes testing and tuning to ensure it functions as expected and accurately detects the intended events or conditions. As the use case is implemented, it undergoes optimization based on outcome from testing and real world application, allowing for adjustments to improve performance. Finally, the use case is continuously monitored for performance, ensuring that it remains effective and responsive to evolving threats. This monitoring brings the cycle back to the beginning, where the requirements can be reviewed and adjusted as necessary, making the process dynamic and adaptable. Let's now discuss on what is a speed framework. The use case framework is a strategic methodology crafted to elevate the efficiency, effectiveness, and overall performance of Security Operations Center. By adopting this framework, SOC can systematically streamline their operations, minimize complexity, and enhance workflow efficiency. The framework focuses on optimizing processes by using a structured approach. Ultimately, by integrating these elements, the SPEED framework aims to create a more agile, responsive, and high-performing SOC. Now here we will discuss on advantages of using SPEED framework. The SPEED framework offers several key advantages for organizations focused on enhancing their security operations. It provides a clear and organized structure for monitoring use cases related to log sources, making it easier to manage and track security events. Additionally, the framework aids in the identification of generic threat actors, improving an organization's ability to respond to potential threats. One of its significant benefits is the clear distinction it provides between different types of threat intelligence, helping teams differentiate between various data and threat sources. The SPEED framework also highlights the difference between attacker-centric approach and the defense in-depth model, ensuring that security strategies are well-rounded. Moreover, it enforces consistent defined naming conventions across the entire framework, which contributes to clarity and uniformity in managing and communicating security processes. Now, in this slide, we will discuss on where speed framework is in the SOC environment. This diagram represents a comprehensive framework for managing the life cycle of security use case within a security operations center. At the top of the diagram is the business risk that are driven by various factors, including threat, risk, and compliance requirements. These drivers set the context for defining and managing security use cases, which are crucial for addressing the risks faced by the organization. The core of the diagram is the use case lifecycle, a continuous process consisting of several stages as explained in the previous slide. External sources such as vendor use cases, threat detection markets, and open source use cases feed into this process, providing valuable insights and resources. Additionally, internal organization-specific information, including asset classification, network architecture, critical applications, and data classification, are critical for shaping the use cases effectively. The SOC itself functions as a central hub, continuously growing and evolving its detection capabilities. This growth is guided by strategic roadmaps, criteria, governance, and well-defined processes. Now, at the heart of the SOC capabilities is the use case library, which serves as a repository for all use cases. The SPEED use case framework is a part of the use case library, which provides structured guidelines for categorizing detection efforts and maintaining consistent naming conventions. Finally, the detection capabilities of the SOC are powered by rule directories and rules, which interact with log sources to provide the data necessary for threat detection and response. This entire framework illustrates a dynamic and continuously improving system, ensuring the SOC can effectively manage security use cases and respond to evolving threats. Now let's move on to categories and naming conventions, which is important for speed framework. To make use of speed framework, it needs to be converted into a directory structure, which will be implemented in the knowledge base and in the rule structure of the SIEM solution. The proposed directory structure for the use case framework include categories such as self-monitoring, access control, application, host, mobile, wireless network, internal network, cloud, perimeter, physical, policy, and attack patterns. This structure organizes use cases across different security areas, covering everything from SOC performance and user access to application security, network protection, and compliance.
Let us start with Sigma rule. As you know, SOC operation team is constantly burdened by the heavy workload. Sigma rule can significantly accelerate their processes, potentially giving the SOC engineer some much needed downtime. Sigma rules are YAML-based textual signature designed to identify suspicious activity that could indicate cyber threat in log event. In simple terms, Sigma is a generic and open signature format that allows you to describe relevant log event in straightforward manner. Sigma rule translate and standardize the threat detection practices, making them accessible and reusable across different SIEM platforms. The rule format is flexible, easy to write, and applicable to any type of log file. Sigma rules are written in YAML syntax, which is human readable and easy to implement. Once you have written a Sigma rule, you can convert it to the format compatible with your target SIEM or platform using the online converter. The primary focus of Sigma rule is to detect log events that matches the criteria set by the SOC engineer. This is particularly useful for the incident responses, detection, and automated response. Therefore, such rules can significantly reduce the SOC engineer's workload by minimizing the false positive alerts to automated responses with precision. However, this rule still needs to be written or imported from the open source library, which can take the time to identify the appropriate Sigma rule for specific cases. Now in the next slide, we will see how to write the Sigma rule. The first step in writing the Sigma rule is to clearly define your goal. This goal can vary widely depending upon your needs. For instance, you might want to monitor specific occurrence within the log events, such as tracking the frequency of certain action or identifying specific type of activities. Alternately, your goal might be to detect the instances of particular string or a pattern associated with the known exploit, helping you to pinpoint potential threats quickly. One of the key strengths of Sigma is its flexibility. Unlike other standards, Sigma does not impose rigid format for writing the rules. This flexibility allows rule writers to tailor their rule precisely to their specific requirements, offering the freedom to create highly customized solution. However, this freedom also means that the rule writer needs to stay disciplined and focused to ensure their rules are clear, complete, and efficient. In practice, this means carefully choosing what to include in the rule to make it effective without adding extra complexity. The goal is to balance covering all the necessary aspects of the rules with keeping it simple, avoiding anything that could make the rule harder to understand. So by doing so, you can create Sigma rules that are powerful, clear, and easy to manage, ultimately improving your ability to detect and respond to the threats. You can see the example of Sigma rule on the slides. So as shown, the basic structure of Sigma rule includes header, which contains the metadata about the rule. Next is log source, specifies the type of the log data that the rule applies to. Next is detection, which defines the condition that needs to be met for the rule to trigger. The field section lists the field to be written in event of match. The next are tags. Tags are used for categorization and linking to the external references. Let us now move to the next slide and understand the advantages of Sigma. I have mentioned some benefits of Sigma rule in the slides. The first is standardization. Sigma rules offers a universal language that SOC analysts can use, no matter which SIEM or log management system they have. This standardization simplifies log parsing and rule creation, as Sigma rules only need to be written once and can then automatically translated for the use of various platforms. This approach makes resource use more efficient and boosts analyst productivity. Next is compatibility. Sigma compatibility refers to the ability of different SIEM system and platform to understand and use the Sigma rules. Because Sigma rules are written in standardized platform agnostic format, that is YAML, they can be converted into specific format required by different SIEM tools. Next is flexibility and cost efficiency. Sigma rules allows organization to evolve their cybersecurity defense in a way that best suits their needs and budget. The ability to convert the Sigma rule to any vendor format gives security team the flexibility to migrate from one SIEM system to another seamlessly without losing the value of the existing rule. These features help organization to avoid the vendor lock-in and make it easier for them to scale their cybersecurity operations as their need changes. Next is efficiency. Sigma rules enable automated detection and reduce manual log analysis. The last is scalability and continuous improvement. The Sigma rule can be scaled across various SIEM platforms, making them ideal for both small and large IT environments. Sigma rule benefits from regular update and improvement contributed by the global cybersecurity community. This ensures that the rule remain effective against the evolving threat. So that's all about Sigma rules. And now let us talk about Yara in our next slide. So Yara rule serve as a crucial tool for cybersecurity expert in detecting and analyzing the malware. To truly harness its power, we must understand its core component and operational dynamics. In the upcoming slide, we will explore the technical details of Yara rule. I'll explain its 5 key parts like malware, strings, and import, show how Yara rule work, and give you the clear understanding on how to create the effective Yara rule. So what is Yara rule? Yara, which stands for yet another ridiculous acronym, it's humorous, but it is a powerful tool used in cybersecurity to detect and identify malwares. Despite the humorous name, Yara plays a crucial role in the analysis of malicious software. It works by using a set of rules which is essentially patterns that can be used to match the specific type of malware. These Yara rules are carefully designed to recognize the unique characteristic of different malware samples. They do this by looking for a specific text string or a binary sequence within a file. For example, if a certain type of malware always include in a particular piece of code, a Yara rule can be created to detect that code. When Yara scans a file and find a match with one of these rules, it can classify the file as belonging to the known malware family. The framework is especially useful for the cybersecurity professional who needs to manage large volume of data. By automating the detection process with the Yara rule, they can quickly identify the potential threat and take the action to protect their system. In a sense, Yara helps experts to describe and catalog different type of malware, making it easier to recognize and respond to new threats as they emerge. Each Yara rule is structured around set of strings, regular expression, and conditional logic. These components are carefully designed to detect the specific bytes of sequence or behaviors in analyzed sample. Now let us understand the main component of YARA in the next slide. The 5 primary elements of YARA rules are: the first is import. In YARA, the import section allows a rule to utilize external modules that increase its capability. These modules provide additional functions or methods enabling the rule to access and evaluate the data type or structures that are not natively supported by YARA standard. Next is metadata. A YARA rule can include a metadata section which provide additional information from the rule's author such as source, description, date, etc. The next is string. In YARA rule, the string section defines the pattern or sequence of characters that the rule look for in the file or a process. These strings are critical because they help to identify the specific characteristic of the malware or other type of data that the rule is designed to detect. Next is conditions. The conditions section in a YARA rule is one of the most important component. It defines the logic that determines whether the rule will match a file or a process that being analyzed. Essentially, the condition specifies the criteria that must be met for a rule to trigger a match. Next is rule name. As per the title, the rule name in a YARA rule indicates the name of the rule. So now let us understand the example of YARA. In the example, the provided YARA rule is designed to detect the presence of lemroot web shell. In the metadata section, you can see the additional information such as author, incident, etc. The string section contains bytes sequence, text or a regular expression to match against the file. And the condition specifies under which circumstances the rule should generate an alert. Now let us move to the next slide and understand the advantages of YARA. You can customize the YARA rule to suit your need. YARA helps you to find specific pattern or sign in the file or data. Another advantage of YARA rule is that it works across different platforms and tools. YARA rule helps cybersecurity professionals to protect their organization from the threats. So now we will move to the next slide and understand how to import YARA and Sigma rule in IBM QRadar. In IBM QRadar, you can download and install IBM Security QRadar Manager for YARA and Sigma rules app to apply YARA and Sigma rule to QRadar event flows and searches. This application includes some of the key capabilities such as import, edit, and manage the existing YARA rules. You can scan raw payload with the YARA rules. You can scan the QRadar events or flow with the YARA rules. You can import, edit, and translate the Sigma rules into the QRadar rule or AQL searches.